Hello. How's it going? Just realized I needed to turn my
Hello.
microphone on.
How's it going?
Just realized I needed to turn my
Hello.
microphone on.
How's it going?
Oh god.
Realized I needed to turn my microphone on.
Let's
Oh god.
turn that off. Okay, there we go. All right. How's it going? Don't let the screen freak you out. It's not that bad. It's really up here I have a terminal running. Down here I have just a document loaded in Emacs. It's the configuration file. It looks crazy, but it's really not. It just has a lot of documentation in the file itself, in comments. It's actually pretty straightforward, pretty easy to read. What I'm working on today is trying to get this shell or a shell like it or a terminal emulator to run directly inside Emacs, so I don't have to have an external one open all the time. Because one of the cool things you can do with Emacs is open a new window like this, and then I can change what buffer is loaded in the window. And you can tile it and everything, and so yeah, I'm trying to get a terminal to run in here. Yeah. Can also just click on stuff. So that's what I'm doing right now. And then later on today, I will be probably working on my Godot game. But one of the things I wanted to do was share the documents that I'm reading and read through them. I think that's something that folks don't get to see a lot, maybe, when they're first starting out. It's just like how much we read documentation and blog articles on new technology. So this is new to me. JavaScript, web development, not new to me. Been doing that since the web came into existence. And the yeah, so, well, not since the web came into existence, but pretty close to that time, since it was like widely popular and JavaScript existed. Yeah. Okay, so what we're doing is using a language called ClojureScript, which is specifically designed, it's a functional programming language, specifically designed to compile to JavaScript. Now, it runs, ClojureScript itself runs in a Java virtual machine. And that lets us do all kinds of cool things, like live reloading the page. There's a job that just watches for changes in files in the project file structure and live updates the project page as you make changes. I think that's super useful. I also like that the language is a little bit more structured than JavaScript. It's a little bit stricter, but that's actually nice because it's also a little bit simpler. The syntax is a lot simpler. And because the language is specifically designed to compile to JavaScript, the designers of the language have just removed some of the gotchas of JavaScript. And so we can spend a lot more time thinking about the problems we're solving and a lot less time thinking about how to write JavaScript. And you should write JavaScript, especially if you're new. You should know how that works. But this is just something new that I'm trying. A few people are using it. Google uses it. Yeah. I can pull up the ClojureScript website real quick, and then I will finish with the sales pitch. I'm not really selling anything. This is the page, clojurescript.org. Why Clojure? Clojure is a dynamic general-purpose programming language supporting interactive development. Clojure is a functional programming language featuring a rich set of immutable, persistent data structures. As a dialect of Lisp, it has a code-as-data philosophy and a powerful macro system. Why JavaScript? I think we all know why JavaScript. JavaScript is the language that runs in the browser. Because of its importance, JavaScript engines are also receiving extensive research and optimization, allowing JavaScript to compete for performance with many more established platforms like the Java virtual machine. Why Google Clojure with an S? As the purveyors of some of the most complicated client-service web applications in use today, Google has invested heavily in creating the Clojure library and Clojure compiler, which work together to make whole program optimization possible, yielding programs that provide minimal load times, even when using many libraries. That's one of the things that the Clojure with an S compiler can do is when it compiles your code, it doesn't just include the whole library in the finished product, in the compiled software. It only includes the functions that are called, and it can follow those function calls recursively as it's compiling. So that is kind of cool. And when I get to doing a build of a game in Godot, you'll see the juxtaposition, right? In Godot, you have to manually include and exclude features of the game engine before you compile. But with this Clojure compiler from Google, we don't have to do that. It's actually a huge help. It saves hours of time in the end. So I guess this company, Nubank, is one of the world's largest digital banking platforms, serving over 65 million customers across Brazil, Mexico, and Colombia. From its start, Nu has a spectacular success story with Clojure, running mission-critical software at scale. In 2020, the company acquired Cognitect, the consultancy behind the Clojure and Datomic database. Okay. So what I want to know real quick, I just want to give an example of who is using ClojureScript. So let's look at that real quick. I mean, I'm going to learn this regardless because I think it's useful, but companies using ClojureScript. Here we go. Below is a partial list of companies using ClojureScript. To add your company to the list, please submit a pull request to the clojurescript.org repository. So we have 8light. I'm just going to see if anything. Okay, American Physical Society. BGP works. I mean, this is Capital One. This is a huge list. Circle CI, Cisco, Cognisys. What else? Duke University. I didn't know that. eBay is using ClojureScript. There are a lot of companies on here. Mastodon C, not on public site. Okay. Navis, Next Journal. Numerical Brass Computing. Open Sensors, nice. What else have we got in here? So these are all the companies using Clojure. There's a lot. Upworthy. University Health Network. Cool. So if you're interested in that sort of thing, clojurescript.org/community/companies. And these are just the ones who have made a pull request to that repository. So, yeah. All right. Let's get into it. Emacs. Emacs is written with Clojure, I believe. Not ClojureScript, but Clojure. All right. Is this a book? Emacs 28, Mastering Emacs. Learn more? No, I'm not going to do that right now. Running shells and terminal emulators in Emacs. One of Emacs' strongest capabilities is its ability to talk to external shells, like bash, or emulate an entire terminal. But this being Emacs, you have more than one choice to choose from, and which choice is right for you? To use Emacs effectively, you must learn to use all that Emacs has to offer. One of Emacs' strongest selling points is its shell integration and terminal emulation. If you come from other editors or IDEs, you're probably using an external terminal window like Xterm, a terminal multiplexer like the GNU project Screen or Tmux, or console window in Windows, and switching back and forth. But there's a better way. If you use Emacs as your shell, you will have all the functionality that Emacs provides, plus you get almost all of the advantages provided by the shell itself, but built into Emacs. This article is only a quick overview, but it's enough to get an understanding of Emacs capabilities. All external interactive shells in Emacs are derived from something called COM-int mode. COM-int mode introduces low-level functions for dealing with interactive shells that require user input, a history ring, and so on. Shells like emacs shell and emacs run Python inherit from COM-int mode. COM-int mode also has the unfortunate job of having to work with a baroque set of systems, devices and rules that are old and arcane. It's true. Yeah. But an important note before I begin, a terminal emulator is not the same as a shell. The terminal emulator reads control codes and updates a grid of characters split into columns and rows. That, in a nutshell, is all it does. A shell is something like bash or cmd.exe or Python. Emacs can do both, but first it's worth talking about how Emacs interacts with external programs. Ooh, this is going to be some fun stuff. How Emacs talks to external processes. Emacs runs on many platforms. The maintainers of Emacs go to great lengths to ensure a uniform experience, where possible, anyway. That includes native Emacs implementations for features that may not be present on certain platforms, or outright workarounds if certain features do not work well at all. When you run a program in Terminal, you're effectively communicating with that program using bidirectional channels. They're usually called standard input, output, and error. So STDIO. If I can go like I know that will redirect to standard out. When you run a program in your terminal, you're effectively communicating with that program using bidirectional channels. These are usually called standard input, standard output, and standard error. Though not all platforms have a dedicated error channel, and some may have even more channels than those three. If you're on Linux, your Emacs is probably using pseudo terminals called PuTTY or PTY. To achieve this, anyway, the fallback, and this is true of Windows especially, is to simply redirect the channels, pipes really, to achieve a broadly similar effect. The fallback is to simply redirect the channels. Okay. Using pipes, like something like that's a pipe. Okay. That's basically how Emacs works. It taps into those channels and communicates through them. It's also how shell piping works when you do cat myfile txt ... Yeah, so like I could go, let's do that right now. Cat wheel main.edn. I'm gonna pipe that into grep and search for all the lines with A in it. There you go. And this gives me all the lines with A in it. So a pipe is a redirect. So you are redirecting the output of one program into the input of another program. Okay, that's basically how Emacs works. It taps into those channels and communicates through them. It's also how shell piping works when you do cat myfile.txt piped to some other application. But talking to external processes is fraught with inconsistencies, bad decisions made in the 1980s that linger on today, platform discrepancies, having to emulate how a teletype or teleprinter device from the late 70s would literally write out characters on paper or screen. The list goes on. That's why if you ever find yourself in the unfortunate position of having to muck around with the command line tools like STTY, then you'll come to appreciate just how much work Emacs has put into this over the last 4 decades. It's very true. I don't think I have it. Let me see if I have it. One of the original editors is called Ed. No. Sure, I'll install Ed. Let's see this real quick. So Ed is crazy. Just to show you how far editors have come. Ed is nuts. Ed is an application that was used when, like, you would write your program line by line, and then when you were done with it, you would have to print your program out on paper. This was before monitors, before CRTs. Let me look at what I'm installing here. Bunch of Python libraries, Xterm, required by Python 2. Yeah, sure. Okay. So yeah, you would print out your program on paper and read it and check for errors manually with your eyeballs, and then you would go back in and you would use ed to name the line number that you wanted to change, and then fix your errors line by line, edit your program line by line. And maybe you're not fixing errors. Maybe you're just adding functionality or something. But yeah, that's the original. And then ed became other things. Like it was updated to sed. It was updated to I think there's a piece of software called help. But yeah, obviously as terminals came out, or as CRTs came out, you needed a different set of tools to edit code effectively. But they still built on top of, the stuff they had built before, because why not? Like, you already wrote a bunch of functions that does text editing. Why not continue to use the ones that are still relevant? Okay, so now I can type in ed. And then this is it. We're in the editor. We're in the editor right now. So I'm going to try typing, like, I know this is nothing, but we'll just pseudocode. Oh, hello. Yeah, sure. Hello code. And then enter to go to the next line. It says, what do you want to do? I'm going to send it the end of file character, which is a dot. And then hit enter. Oh, maybe, shit. I don't remember how to do this. I have to look it up. Does it want a file name? Hold on a second. This is pure. I do not recommend using ed at all. This is purely for historical purposes. I think it is cool that you can still go out and get it from the internet and install it and use it. Like, it's a testament to its design and usefulness. So yeah, ed cheat sheet. What am I doing? Why am I going down this rabbit hole right now? It's all good. That's what I like to do, I like to really know things and the history of things, these artifacts that we interact with every day. Gotta change my dark reader to off. On. Can we? Is this just a terrible website that has bad colors? That does nothing here. Your dark reader mode plugin has no effect on me. Why yellow? Okay. Print current line, editing, printing, buffer operations, reading and writing. Write file is W. Okay. And then do I need to give it, I think I need to give it a file name. Yeah. A path. I'm going to give it a new, see if it can create, let's test it. See if it can create a new directory. We'll do ed sample directory ed sample dot pseudocode. No such file or directory. Okay, so it can't create new directories. So if I was in this situation in the olden days, I would have to send this program to the background with Control D, I believe. Let me double check that. Logs out of the interface used. Oh no, that sends the exit. Maybe it's Control Z. Control D is EOF. Control Z. That's to stop. Control X. Okay. Shell send application to the background. Oh, it's Control Z plus BG. So you have to stop it. So if I go Control Z, and that's fine. We can stop it, and then we'll resume it. Because what I wanted to do now was create that directory, make dir home ed sample ed sample dot pseudocode. Sure. Oh, nope, just the directory. I only need to make the directory. There we go. Okay, so now to resume, I can do, no, I don't want to do BG. To view and manage processes in the background, use the jobs command shell. This will show background jobs in a terminal session. Jobs. So ed is suspended. That's correct. That's what we just did. To bring it to the foreground, use the fg command with the job ID. Oh, okay. Right. Man, I haven't had to do this in a while. fg1 job not found. Maybe I can just do fg ed. There we go. Okay. Cool. So what we just did is something kind of cool in the terminal. So I'm running this application called ed, and it is a text editor. It's like one of the very old, most basic text editors. This is the list of, I don't think this is an exhaustive list of commands, but it's a lot of the primary commands. So now, if I want to, can I read the file that I just wrote, or did we just destroy it? Buffer operations. Printing. Print the entire buffer. P also prints the entire buffer. So do I have to hit comma P like that? Is that? No, that doesn't comma P. Weird. $1 1 P. Okay, I'm gonna start all over. So I'm just gonna kill this. Hit Control. Oh, Control C doesn't work here. Okay. Perfect. Nope. So it looks like when I suspended it, it didn't keep what was in the buffer. This is why we don't use ed anymore. Print the line marked as exe. Start editing after the current line. Sure. Okay, so let me just write that again. And then we hit enter. And then dot, I believe. No? Or just enter on a empty line? Yeah, okay. And then let's try to write this again. Write home. No tab completion. Home, what was it? It was ed sample. I'm gonna cheat. I'm gonna open a new tab over here. CD home grep, because I cannot for the life of me remember what I named it. CD home grep ed grep. CD home, or she's ls home grep ed sample. Okay, go back here, ed sample, ed dash sample dot pseudocode, something like that. I don't know. No such file or directory. W. Wow, this is way off topic. Anyway. Does it not understand? Oh, man, what? Home. Low tech. Ed sample. Ed sample. Oh my god. Okay. So now I can read home, low tech, ed sample, ed sample. No such file or directory. Well, okay, I'm done with this for now. How do I exit this thing? Let's see. Add Unix text editor. Let's see. This might be a better Oh my god. Can we just get a web page, please? Nope, this is also a PDF, whatever. I'm just gonna Google how to exit ed. To save the file, use the wcan. If you really do not want to save the recent changes, use the quit. Or E to edit a new file. So I can use Q. Q. Goodness gracious. So I'm actually going to CD that folder I just made just to double check that, or not CD, we'll list it. And it was home ed sample. There's nothing in here. So, yeah, ed is hard to use. I'll look at that another day. All right, so let's get back to this. Let's get back to this document. So we're talking about how difficult and fraught the old technology is that still linger on today. That's why, if you ever find yourself in the unfortunate position of having to muck around with command line tools like STTY, that you'll come to appreciate just how much work Emacs has put into this over the last 4 decades. When you type m-x comment run and you give it a program to run, it'll probably work fine, at least on 21st century platforms. There are a couple of things that may lessen your experience. Input echoes when you send text. ANSI terminal escape codes don't render or work well. Emacs does not understand the prompt and won't provide history or completion. Line endings aren't stripped properly. And the prompt may not appear at all. Luckily, these things are fixable. And usually, if you're running specialized commands like mx run Python, then it's most likely set up correctly already. In Emacs parlance, when you run a process, it's usually called inferior. The inferior shell mode. Okay, I have to run and use... whoa, my duck is losing tracking. There we go. That's probably better, I think. Yeah. All right. I have to go and use the restroom, but I'll be back. right. Hello, we're back. Yeah, so I'm going to continue reading this article about running both terminal emulators and shells in the Emacs text editor. We're sort of turning Emacs into an IDE. So it says if I type emacs shell, Emacs will spawn a shell using your platform's default shell. On Windows, that's usually cmd.exe, and on Linux, it's often bash. I think I'm using so who am I, the command? No, that's my username. What is the shell? If I go, excuse me, about, it's GNOME terminal, a terminal emulator. Okay. Can I do like sh-i or something? Oh, that gives me an interactive. That's not what I want. That gives me an actual interactive shell. All right. Well, fine. Let's go into Emacs and load up a shell. I don't actually have to type emacs. I can do space for fuzzy matching and then type shell and hit enter. And that will give me a new shell. With some warnings, cannot bind to an empty key sequence. Okay, so if I ls, let's print working directory. Cool. So let's look up the command to see what shell we are using. How to see what shell. I had to check shell version. There's a global variable called shell. Let's see if that's true. If I go echo ZSH, there we go. Now let's see if this actually works. If I go shell -- version, awesome. Oh, it does echo the it echoes whatever you type in. That's a little annoying. Can I use clear? No. Okay. And then I can close this buffer by hitting space. What was this all just? Wow. Okay. So space is not working here. Do I need to type exit? Can I use space now? There we go. And then I can close this buffer by typing in B and Q, or B space B close space B X. There we go. And then I'm back to the buffer I was already in. One of the other cool things I can do with Emacs, let's open up a new, again, I'm still learning all of this stuff, so let's open up a new window, I think is what it's called. Windows. That's not what I meant. A frame, a new frame. Okay. CX52 for make frame. So I'm gonna try that. Let's go back here, hit space. CX is undefined. Colors. Okay. I'm actually using a configuration called spacemacs. Cool. Yeah, for all you web designers out there, these table of contents should automatically collapse after a certain window size. Okay, so if I go space, let's get in the right, space F N is undefined. If I go space W, window, one split single column, double columns, grid, equals for balance, split window right, slash. Okay, cool. Now we've got a new window with a buffer in it. And then I can go space, I can open the terminal now, run that shell again. So I can hit space over here, space for fuzzy matching, type in shell. Yes, give me shell. There we go. So now I have my document on one side and a shell on the other side. PWD. Of course, it doesn't look as pretty as my terminal emulator up here, but yeah. And then if I want to quit this, I can type exit, space, nope, make sure I'm on the escape. Oh wow, that's interesting. So let me space, let's open shell again. So I'm actually just in an editor window that is operating as a shell, and I'm in insert mode because I use the VI or the Vim keystrokes. And if I exit, then I can space. So I hit escape and exit input mode. So I goes to input mode. Escape. Oh, that wasn't escape. Escape exits input mode. And I can hit space now to get my menu. And then I want to close the buffer, so B to select the buffer, C to close it. Space, B to select the buffer, X to close it. Buffer shell has a running process, kill it, yes. Cool. That's pretty cool. So let me do that again. If I want to open a window, I can go space W slash, and then how do I move to that window with the keyboard? Oh, it was up here, wasn't it? It's space. jumps to window number. Window numbers are down here in the corner. So if I'm in this window, I can go space 2. There we go. And it'll jump to this window. Now I can go space space, type in shell, and load a shell. And then I can minimize this window. You can close it. You can delete it. I can maximize it. Cool. I'm just going to not get too much further into this. Hit space, well, escape space, buffer X to close the buffer, yes to terminate the process that was running. And I'm going to go back to my home buffer here. Space, B for buffer, H for home. Cool. Okay. All right. So we just typed in emacs shell and saw that we can run, we can access our default, our platform's default shell. If someone was chatting, I apologize. My browser seems to have froze. Are things working now? Hard to tell. I think so. Let me check my duck. Duck seems to be working. Okay. All right. So we just access the shell. emacs shell is not a terminal, as I explained earlier. That means it's not meant to be used with interactive terminal programs like Top. But that's not a bad thing. Instead, it's a trade-off. You see, emacs shell is a fantastic terminal replacement. You replace the terminal with common Emacs primitives. You can move around and edit and search and use any feature you like. Already here, in my opinion, does it greatly exceed the utility of your typical terminal emulator. It works like any other buffer. That also means you don't have to fight with it to mark text and copy it. That can be done with any number of common Emacs commands. And because it's an Emacs buffer, you gain a large number of useful additions. Built-in completion. Emacs emulates the tab completion you find in tools like Bash. It's not as expansive as Bash, and extending it isn't that easy, but it's generally good enough for a large swath of things. The primary completer for commands is pcomplete, a completion tool originally built for eShell, but more eShell later. If you want to see what Emacs is capable of completing in shell mode, you should look at the variable chv shell dynamic completion complete functions to see all the PC completers your system uses. Look at cucha PC complete. So let's try that in here. So we're gonna go space Shift C. Yeah, see, I don't get the same. That's not defined. But I know how to look at space. I can look maybe shell dynamic complete command, file name, environment variable. No. So that's something I don't know yet. Like, what is this? Why don't I have C in my, like, my C is only Helm colors? Like, what? I think C or capital C is for configuration. I need to look that up real quick. I don't want any of this right now. Okay. Actually, did I leave that in the buffer? No. Okay, we're fine. So let me look that up. Space max C. Space max C dash H, I guess, is what we're looking for. Let's see. C dash H. Okay. No. I thought that. Layer list, maybe? Let's see. Layer for your IRC chat. Jabber. Wow, you can have a Slack layer in Emacs. Helm. IV. Templates, email. I am liking Emacs less and less. Yep. I mean, there's some things I like about it, but it's kind of a mess. And part of it is the way people talk about it. Like I'm supposed to be able to just type in CH. The place that I know to type in CH is here. Yeah. And I just, well, let me go to the right buffer. And now I'm just, what's going on here? That's my messages, don't care. Escape, space, buffer home. C-C, C-P, and C-C, C-N to move between prompts. Like, there's no way. Specialized movement. Oh, is that only when the shell is open? Okay. That may be my mistake. So let me open a shell again. Space, space, shell, space. So exit input mode, space, C. No. Switch to completion buffer. Or compilation buffer, helm make projectile, show hide compilation window. I'm down here, hide show comments toggle, kill compilation. yeah, that's super annoying. Right click to close. Hmm. Hmm. Yeah, I'm not sure where I'm supposed to find. Does it just not exist in my version of Emacs? It's so weird. If you want to see what Emacs is capable of completing in shell mode, you should look at the variable c-h v I'm gonna look that up, I guess. Why am I using Emacs? I don't remember anymore. Emacs provides a wide variety of help commands, all accessible through the prefix key c-h or equivalently the function key F1. These help commands are described in the following sections. You can also type c-h or c-h to view a list of help. Is that C is command for command? Is that what that means? So if I go, no, space H, so this was telling me to run HV. So, not there. That's not what I want. Space, help, V is undefined. Okay, I'm going to read this a little bit more. Emacs provides a wide variety of help commands, all accessible through the prefix c-h, or equivalently the function key F1. These help commands are described in the following sections. You can also type c-h to view a list of help commands, help for help. You can scroll the list with space and delete. Then type the help command you want. To cancel, type c-g. Many help commands display their information in the special help buffer. In this buffer, you can type space and delete to scroll, and type return to follow hyperlinks. If you're looking for a certain feature but don't know what it is called or where to look, we recommend 3 methods. First, try an apropos command, then try searching the manual index, then look in the facts and the package keywords. C-H-A topics return. This searches for a command whose names match the argument topics. The argument can be a keyword, a list of keywords, or a regular expression. Okay. But, okay, so space, if I space H does get me to help. That got me to the documentation. I feel like the creators of this oh my god, this is what I'm looking for though. So I want to type, I think this is what I wanted, right? No, I wanted H. Well, what if I type this in now, over here? Seriously. How do I, what? I mean, like, huh? How do I get my thing in the search pattern? That is so weird. I'm just exiting this buffer. So let's try that again. Space F. I think that's find. It's not really what I want. Maybe it is, I don't know. Space F. Helm find files. No buffer named Helm Spacemax. Sure, fine, whatever. Did I just blow up my editor? God, this is the most frustrating thing I've ever done. I can't believe it. It's just not working. So let's kill it and restart it. And then if I go space, now it works. So I'm still confused about what this C CH or F1. So let me try pressing F1. Help command. Info. CH paging help. Okay, so why can't I whatever. So now I should be able to type in What was I looking for? CG, actually. CH. So that was over here. It was telling me CHV. So if I type in V now, no? Nothing? So let's try it again. Space. Type V to expand again, V to contract, R to reset, E to edit, slash to search, F to search in files, B to search in open buffers. V. No. No. Go away. I don't want any of this. I need to do something here. I need to, I don't know, space, tab, hit F1, V. There we go. So what is this C-H? I don't, is that command control? Maybe? Try that in a second. Describe variable. The variable I am looking for is shell dash dynamic complete functions. Yes. There we go. Shell dynamic complete function is a variable defined in shell.el. Its value is com_int-c-a-p replaced by expanded history. Yeah, okay. Sure, I'm not going to read all of that. List of functions called to perform completion. This variable is used to initialize com_int dynamic complete functions in the shell buffer. This variable may be risky if used as a file local variable. You can customize this variable. Customize option. Sure. Why can't I? There it is. So we can decide what kind of completion we want. We can set it in here. Cool. All right, let's get out of here. Skedaddle. I'm gonna go space B, close. Right, so now we're in the help buffer. Cool. So I pressed F1 to get here. What happens if I do control, nothing, space, control, nothing? What the hell does C mean? What does that mean? So frustrating. If anyone in chat knows what that C stands for, because like space buffer close. Oh no, it's X space buffer X. Maybe I have to do it from here. Shift C. Shift C is undefined. Okay. What about command or control? Space H. I think I have to go space H space. Ha. No way. So that's the keystroke. V. Layers. Okay, nope, that's not what I wanted. So weird. Man, Emacs is frustrating. Is it because I'm using Spacemacs and not Emacs? I don't know. I don't know. I'm not an expert here on this particular editor. Let's escape. All right, space, buffer, close. So as far as I know, to actually open up, you have to hit F1, and then I can hit V to search variables. That's good enough for me. I mean, I'll just have to remember that. Oh, no, we're good. Okay. Built-in completion. History ring. Emacs history tool is much better than the simplistic one you get in the GNU read line. The tool most shells use for history completion and such. To get an idea of what the differences are, you can read about the shell and commit history commands. Sure, not right now. Specialized movement in editing, like C-C and C-P and C-C, C-N to move between prompts. Okay. Delete output of the last command. Jump to the beginning of the command's output. M-R to iSearch through your command history. To show the history, you can cycle through your history, and of course you can apply the entire arsenal of Emacs keys and commands as it's a plain old buffer. A common complaint about shell mode is the anemic support for ANSI terminal control codes. Emacs built-in ANSI color library is serviceable but basic. If you want better control code emulation, you can give Xterm color a try instead. It does come with a number of trade-offs, but if you want better color emulation, then it's worth trying out. Changing the shell program. You can change the default program shell mode uses, but note if you're doing something esoteric, you're going to have to change quite a few variables, as every shell has its own unique set of challenges to deal with. Here's a simple example that uses ZSH. Well, that is the shell that I'm most comfortable with. So we're going to explicit shell file name, user bin ZSH. We're going to set shell file name, explicit tags, shell mode setup, set local comment process echoes true, add hook, shell mode hook, ZH shell mode setup. The way this works, the way that Clojure works, or ClojureScript, or any Lisp really, is this is a function, and then these are arguments. And I don't remember what the pound sign does, but this tick here means that this is to be interpreted literally. So we have the function and its arguments. Function call, rather. Same here. This is the function call and its arguments. In this case, it's very likely that set q local comment process echoes. So do we want process echoes on comment? And that is going to be true, set to true. So this is the probably like a function that looks up a key and then can change the value of that is associated to that key. And so it takes two arguments, the key and then the value that you want to set that key to. Yeah. Same thing here. Functions. In this case, this is a function that takes a function. And then it has a series of arguments that are strings. It's actually like, what it's doing is it's taking a single argument that has a single argument of two arguments. Whatever. I would have to go look at that function to see why it's doing that. Anyways, this setup makes a number of assumptions, like that Emacs knows about the prompt, and if it's the default ZSH prompt, it probably will. Otherwise, you'll have to change shell prompt regexp so it's correct. Next, it adds a mode hook that processes echoes. This stops duplicate input from appearing. Now note the variable explicit ZSH args. It's not a built-in variable. The file name portion in explicit shell file name is extracted and checked against a variable named explicit file name args. I've set it to call ZSH with --login and --interactive. The latter may or may not be a requirement. Some programs, when they detect the output and input is redirected, disable the prompt. So if the prompt is missing, you want to ensure the shell runs interactively. And that's it. That's the bare bones setup for another shell. This setup leverages a number of hard-coded assumptions that shell mode sets if it detects the shell is ZSH. If you want to fine-tune things, and if you know a little eLisp, just read the docstring in c-h v shell mode. It'll list most of the variables you'd want to configure. If you're running into issues, you should instrument and step through the shell mode function, or at least read its code to see where things are going wrong. Directory tracking. Okay, that's coming next. So one of the things that is kind of bothering me about Emacs is that it doesn't have a modern interface. You know, like, that is really kind of a problem I feel like it's downplayed about this editor. It doesn't have a modern interface, and it's not like particularly fast. And that's really kind of what I want, is I want something that doesn't feel like it's like loading all the time. I want it to feel like snappy, like, yeah. And it also does some things that you just shouldn't do, like that. Like things happening seemingly out of nowhere, you know? It's fine that, so clicking in here, so this was, we assume that, and maybe I'm just making faulty assumptions, but yeah, and look, there's no way for me with my mouse to expand this, and I get you're not really supposed to use your mouse, but then take away the option to use the mouse, because the mouse feels incredibly unpredictable in here. you know, and we all have mice. We all use them. So I'd say like that's one of the things so far that I like better about VI is that VI is not confusing. It's difficult. There's a learning curve, but it's like very predictable. And if I look something up on the internet about VI, it's very likely going to be correct. Yeah. But VI has kind of the same problem as Emacs in that, like, to get it working as an IDE or, you know, as a, you know, a good, like they both VI and Emacs have the equivalent features of, say, like VS Studio Code or something like that. And even more, if you are willing to configure it to do those things. But one, I don't really need all that functionality. Like my primary goal is to edit programs efficiently, you know, do programming. And it definitely needs to be predictable and easy to talk about. And that's one of the things I'm finding is that it doesn't seem that easy to talk about. Like, I don't understand, and maybe it's because I'm using this configuration called Spacemacs on top of Emacs. So maybe they've changed some of the command things. Maybe I'm just ignorant to some of the conventions. But it seems like things are not the same across all versions. Yeah. And then that would be also Spacemax's problem as well, because Spacemacs bills itself as like, oh, the, you know, the version of Emacs or the Emacs configuration plug and play that will get beginners into Emacs. But I'm not finding that to be the case, honestly. When I'm looking up information on how to use Emacs and Spacemacs does it the Spacemacs way, then that's not helpful. But anyway, I did figure out how to get a terminal emulator up, and so I think that's where I'm going to pause on this for now. I might uninstall Emacs or Spacemacs and install Emacs, the default version, instead. I mean, I'm sort of worried that like vanilla Emacs is just not going to have, that it's going to be require a lot of configuration to get it to feel modern. But the reality is Spacemacs honestly doesn't feel that modern. Like any current version of it doesn't feel that modern, and it doesn't seem that predictable. The interface isn't predictable. So yeah, that's where I'm at with that. But now it's time to actually. So I'm not giving up my shell up here. I am going to bookmark this article and come back to it at a later day, and I have time. I'm not in a rush for anything. I'm going to think about this. I'm going to think it over a little bit. But yeah, we'll save this. Save this article. I can open a shell now. So if I hit, I have to remember now. I'll try to remember space, space, escape, click in the window, space. How did I get shell S? No. Oh man, I gotta look it up again. MX shell. So MX is space and then space again. And then I can type in shell. There it is. Now I have a shell. Insert PWD. Yep, and then I can exit the shell. Space. I could open a new window. Space 2. No window number 2. Space slash for new window. You're not in a project. Space window. Split window to the right. Then I can open like file tree. Let's open a open a document. Sure. You cannot remap these functions in map edebug. I mean, this is just constant. Originally mapped on G. This is just constant with Spacemacs. I just like it wants to be automatic and nice to use so bad, but like it's just constantly in my way. Like, and it doesn't even, I don't even have a prompt of like, what am I supposed to do next here? You know, edebug go non-stop mode means nothing to me. Originally mapped on G, okay. What was it trying to, cannot remap these functions in map, edebug mode map. All right, so it's just already mapped. It wanted to sure, I don't know. Can I please, why are these, oh, because they're pointed at the same buffer. And also this tree is not a this tree is not a window, or it's not a frame, but it's a window. It's a frameless window. How do I switch to it? Like if I space 2, let me go out of insert mode, space 1, space tree. No. So I can go space F tree and close it and reopen it, and then I'm in there again. But like, yeah, kind of annoying. Let me try opening this file again. Will you open? It will. And there is nothing in there. That's strange. I don't understand. I'm going to close this buffer, space buffer X for close. And then I'm going to also close the tree. And then I will switch to my home buffer. Space buffer home. All that stuff is cool. All that navigating stuff is cool. like being able to navigate on the keyboard is great. I feel like you can do that with literally any editor. And the other cool thing is having VI mode for modal editing, but I feel like that also exists in most modern editors as well. Also, it exists in VI, in Vim. So, yeah. Well, I'm going to keep working with it. So far, it's been annoying. Moving on. Did I bookmark this? I did, right? Okay. Going to take a quick break. And when I come back, we're going to look at we're going to keep using Spacemacs, and we're going to look at this chapter of Learn ClojureScript. What we're doing is we are connecting our application to live reloading and then building out a little weather application. We're writing everything in Clojure or ClojureScript rather, and all of that gets compiled into the appropriate JavaScript and run in the browser. It's a cool way to develop for the web. I'm actually gonna go. Yeah, we'll just start at the top. All right. I'll be back in a couple minutes. Okay, I'm back. Oh god. I left my mic on and everyone heard me. Everyone probably heard me talking to my dog. Peed in the house. Great. Super fun. Anyway. Alright. What am I looking for here? Turn desktop audio on, even though there isn't a lot of desktop audio. And then turn this on. Okay. All right. The next thing we are doing is lesson 6 in Learn ClojureScript. In the last lesson, we only executed one command. But we already have a basic project that will compile. And as we will see in a moment, automatically reload. Figwheel is the tool of choice in the ClojureScript community for reloading code and executing ClojureScript inside a web browser. Interactive development has been a huge priority for ClojureScript developers, and the instant feedback afforded by a tool like Figwheel delivers on making development a truly interactive experience. In this lesson, we will learn how interactive development is the cornerstone of ClojureScript, use Figwheel to compile and load it into the browser instantly, and learn how to write reloadable code. In order to better understand how Figwheel can streamline development, let's fire it up and see it in action. Since we generated a project using clj new with the Figwheel main template, it included an alias that we can use to start Figwheel with a single command. So what I'm curious about is, can I do this from Emacs? I think I left so if I space buffer, yeah, okay, so I left a shell open. So let me see if I can cd, oops, I wasn't in insert mode. Just gonna hit escape, insert, cd to projects, I think it was called no matches, cl no matches, learn cljs, weather, there we go. Cool. Now I should be able to type clj dash a fig build. And we should be getting getting some output. That's good. And then it opened in the wrong screen. But there we go. So now you open a new window. Open a new window is space. Open a new window is, oops. Okay. So we want to get out of insert mode, space. I think was it W? This should tell me tree max, select window. Space W. Double columns. What if I want to open a window on top or below? Split window below. is minus, I think is what it's saying. Space W minus, so I have a new window below. And then I can get to that window by going space 2. And then I can change buffer, or actually all I need to do is go space F file find. And then I can search through this for my source learn CLJS weather.clgs. Sweet. And then if I do, let me do space tree. Yeah, cool. And then the tree will show where we're at. And then I can space file tree to close it. And then I'm using HJKL to navigate. Yeah, that's from Vim. And it's modal editing. It's using all the Vim keybinds. Or we're using all the Vim keybinds. Cool. All right. Running Figwheel. 1. Enter the project directory. Start Figwheel. That's what we just did. Figwheel will take a few seconds to start up and compile the existing code, but once the output indicates that Figwheel is ready to connect to our application, we can open a browser and navigate to HTTP localhost. That's where we are now, over here, and see the application running. Reloading ClojureScript with Figwheel. What happens when we start Figwheel is that it begins watching our project for any changes to the ClojureScript source files. When any of these files are changed, Figwheel compiles them to JavaScript, sends the JavaScript to the browser, and executes it. Testing live reloading. Now that we have an application running with Figwheel, reloading code on any change, we can open a text editor and change some of the code. So that's what I just did. We opened our weather.clgs or application file. The template that we use to generate a single source file at source/learnclgs/weather.clgs by default, and we will restrict the exercise in this lesson to this single file. Before we make any changes, let's walk through the contents of this file at a high level. All right. So if there's anyone in chat that wants to go over the fundamentals of Clojure syntax, we can do that. It's really simple. Just let me know in chat if that's what you want. But for now, I'm going to continue. So that's what the application looks like. Got some function definitions. Mount app element. Got some function calls in mount app element. Yeah. Got some HTML in here. See that? Do we even have CSS? I think CSS is in a separate file in this case. It's actually in a CSS file, but we can also write CSS we can also write CSS directly to the browser. Or I think we could even write CSS to a CSS file if we want to. But we're not going to do that yet. Namespace declaration. Data structure to hold all UI state. So this is numbered. Declare and render a reagent component. So reagent is the React wrapper for closure script. Optional hook into Figwheel's reloading process. So these numbers are in the comments here. So let's go through that. Namespace declaration. Namespace declaration is up here. Learn Figwheel hooks, namespace ns. Figwheel hooks, learn cljs.weather. So namespaces are roughly the equivalent to a class name. Like in a sense, class names namespace classes. Yeah. But anyways, what that says is these functions will be available at this, under this namespace. Okay, number two, data structure to hold all UI state. Okay, so we're defining the hello world data structure here, or not here. Define def once app state Atom. There we go. Define your app data so it doesn't get overwritten on reload. Okay, so that's number 2. Data structure to hold all UI state. All right. Declare and render a reagent component. Okay, so that's number 3 is the reagent component. That has the HTML in it. Optional hook into Figwheel's reloading process. Optional hook into Figwheel's reloading process. Specify reload hook with after load metadata. Optionally touch your app state to force rendering depending on your application. That must be this here. Okay. After load, on reload, mount app element. Mount app element when let element get app element. Get app element. GDOM get element app. So GDOM is a function library. So this is what namespaces look like. So GDOM is the namespace. Get element is the function available under that namespace. What you would see in object-oriented programming is like GDOM.getElement or something like that if you were accessing the method of a class. But this GDOM is not a class. It is a namespace. It is just a way to group functions in a logically cohesive way. It doesn't have any other mechanisms that classes might have. Very, very simple. Okay. So get element app. And where is app? App is coming from somewhere. I'm not sure quite yet. Anyway, so the optional hook into Figwheel's reloading process. So this is what reloads. This is the live update portion. So let's start by making a minor change to the hello world component. We will add a bit of extra text just to make sure that our changes are picked up. Def n hello world div h1. Okay, so we're going to come over here and we're going to do that right now. We'll make that change. And actually, I'm going to open, so H1 I say, I'm going to open this so we can see it change. So here I'm going to switch to insert mode and type in quotes like that, I believe. Probably need a space there. I say, is that right? Colon. Okay. I probably didn't get the syntax right. Nope, that looks correct. Let me add a space here so that renders properly. Once we save the file, we should quickly see the browser update to reflect the extra text that we added. Next, let's do something slightly more interesting by changing the text inside app state to something other than hello world. Okay, so let's reload real quick. So I'm going to exit insert mode, space, or not space, and I guess you can save from space, but I'm not going to do that. I'm going to escape. I'm going to make sure I'm out of insert mode in normal mode. Hit colon W to write. That'll save it. Okay, and then we see that our app updated over there. Successfully compiled. Outputting main file. Go ahead and edit it and see reloading in action. Okay, so let's do the thing that was more interesting, and we're going to write something other than hello world. So again, using K to go up, J to go down, H to go right, L to go left. I'm going to go up to this line here, and let's change this text to, I'm going to, okay, this is something cool about the Vim key bindings. So I can go to the beginning of, well, it doesn't even matter where I am in this word. I'll go here. I can hit DW. Oh, that was, okay. I guess it does matter. DW deletes the word, and I can add a new word. I'm going to go into insert mode, world, like that, and then exit, and let's bring up our screen here, and then write. Oh, we didn't change our text, did we? So I want to go to change word. Let's call this hello code, and then escape, colon right, enter, and hello world hasn't changed. Why is that? Let's read on. Once we save the file, we should quickly see the browser. Oh, not that. If we save the file again, we'll see that nothing in the browser changes. Yep, that's what we saw. The reason that nothing changed is that we are using def once to create the app state. Right here, def once app state. Using def once ensures that whenever the cljs weather.core namespace is reloaded, app state is not touched. This behavior can give us a large productivity boost. Consider the scenario of building a multi-page form with some complex validation rules. If we were working on the validation for the last page in the form, we would normally make a change to the code, reload the browser, then fill in the form until we got to the last page, test our changes, and repeat the cycle as many times as necessary until we had everything to our liking. With ClojureScript and Figwheel, on the other hand, we can fill in the last few pages of the form, then make small changes to the code while observing the effects immediately. Since the app state would not get reset when our code is reloaded, we would never have to repeat the tedious cycle of filling out the earlier pages. So in def once, we could set all of some test answers to a long form or a multi-page form, and we don't have to type that in manually or load it in manually. It just def once will help to maintain those values even if we're changing other things in reloading and live loading and stuff. So that's cool. Need a little drink of water. Change the hello world component to render a p tag instead. Sure. So this component down here, so let's change, I'm going to change h3 to p. Oops. What the hell did I just do? Oh, I pasted. Undo. Gonna go to insert. And just a P like that. And then normal mode, right? Let's check. Cool. Yeah, looks like it worked. I'm going to change it back real quick with that there. So delete word, insert mode, H3. Does it change automatically? No. Escape, save the file, and then it changes. So I do change word, P, escape, right. Cool. Change the hello world component to render a p tag instead. Create a new component called greeter that renders hello your name, and update the call to the RDOM render to use greeter instead of hello world. Okay, so let's go hello world, RDOM render hello world. Okay, so let's create a new function in here. Go to insert and def n. What do we call it? Greeter? Call it greeter. And then we'll use the same structure that they did. Div and then this will be enclosed in an h1 tag, and it'll say hello, comma, hello, comma, your name, or low-tech. And then I think that's it. I think that's all I need. Yeah. Yeah, that should be good. And then in the render, we can say greeter. Let's go back here. Escape. W. Nice. All right. The live updating is pretty sweet. So you can see how there's like layers here. There's layers. There's like data layers. There's the renderer layer. There's the component layer. And we can use all of those. And I wonder if I could even go to like add another renderer here. Oh, no. Escape. I need to go to insert mode. Tab. Okay. Don't tab then. And then RDOM. Can I call this twice? Is that okay? We're about to find out. And then we'll do hello world. Yeah. Oop. Element. I think this is fine. Oh, but then I need to move that down here. And then let's exit or go to normal mode, write the file. Let's check. No, there is one RDOM. Okay, what if I pass it both arguments? So let's DD that line, and then go to insert here, greeter, and can it do both like this? Will it just do them in order? And then normal mode, right. There we go. Now we got an error. Could not read. Closure link, expected EOF while reading item 7 of list starting at line 27, column 1. Oh, I'm missing, I deleted that, let's go to insert. I deleted this. Yeah, alright. Let's exit insert mode, save it. No, okay. So, I'm not sure how components work, but I'm sure we'll figure it out at some point. So I'm going to delete this word so I can just go actually, let's go DW, W. Yeah, this should work. Cool. We're still functioning. Do I need an IDE? I'm going to skip this. You don't need an IDE. If you're used to it, then yeah, sure, go ahead and use it. In addition to reloading ClojureScript code, Figwheel also takes care of reloading any style sheets that we may change as well. The Figwheel template we used when creating this project configures Figwheel to watch any styles in the resources public CSS directory for changes. To test this out, we will open the default style sheet and add a couple of styles. So let's open that now. We can go space F to find. We are going to look for, what is it called? Style. Where is it? Resources. Okay. Weather. Resources. Public. CSS. Style.css. Now let's type in what they... Oh. Insert. Background color. To AFF color yeah, cool. Is this not a color? 02A 4FF. That's what we're missing. Wow, that's pretty cool. It shows you the colors right there. I mean, I think most was not expecting that, even though most editors do that. Font family, Helvetica. I'm gonna put a space here just to be consistent. Arial, sans serif, font weight 300, and cool. So now we'll go to normal mode, W to save, and then yeah, look at that. Look at that. Colors changed. Updated immediately. Writing reloadable code. Alright, so this is going to get a little heady, I think. Having Figwheel reload your code is a great help, but it's not magic. We are still responsible for writing code that can be reloaded without adversely affecting the behavior of our application. Later in this book, we will be building several applications on React.js and a ClojureScript wrapper called Reagent, which strongly encourage a style of coding that is conducive to live reloading. But we should still familiarize ourselves with what makes reloadable code so that we can still take full advantage of live reloading, whether we are using one of these frameworks or not. There are many considerations that go into writing reloadable code, but they essentially boil down to three key concepts, which we will consider as the pillars of reloadable code. Sure, okay. Idempotent functions, def once, and display business logic segregation. Yo, this is just important. This is just an important concept for writing maintainable code. Yeah. All right. The pillars of reloadable code: idempotent functions, def once, and logic segregation. When we write code that holds to these three pillars, we will often find that not only do we end up with reloadable code, but our code often ends up being much more robust and maintainable as well. With that, we'll dig into each of these pillars and how to apply them to our code. Idempotent functions. An idempotent function is a function that will have the same effect whether it is called once or many times. For instance, a function that sets the inner HTML property of a DOM element is idempotent, but a function that appends a child to some other element is not. Okay. Non-idempotent function. So we define append element, sure, the arguments parent child, dot append child, parent child. Okay. Set content, elem content. Set this dot inner dot is kind of like this. Inner HTML element content. Okay. The append element function is definitely not idempotent because the effect will be different when we call it 100 times than when we call it once. The set content function, on the other hand, is idempotent. No matter how many times we call it, the result is going to be the same. When working with live reloading, we should make sure that any function that is called on reload is idempotent. Otherwise, the side effects of that code will be run many times, leading to undesirable results. You try it. Write a version of append element that is idempotent, and that will only append the child if it doesn't already exist. A possible solution is given below. Def once. When we have scaffolded a fig wheel project with the reagent argument, the namespace that it generates uses a construct called def once to define the application state. As we mentioned above, def once is similar to def, but as its name suggests, it only binds the variable once, effectively ignoring the expression on subsequent evaluations. We often define our app state with def once so that it is not overwritten by a fresh value every time our code is reloaded. In this way, we can preserve the state of the application along with any transient data while the business logic of our application is reloaded. Another useful pattern for using def once is to protect initialization code from running repeatedly. A def once expression takes the form def once name expression, where name is a symbol that names the variable to bind the expression, or to bind an expression is any ClojureScript expression. Not only does def once prevent the variable from being redefined, it also prevents expression from being reevaluated when the variable is bound. That means that we can wrap initialization code with a def once to guarantee that it will only be evaluated once, regardless of how often the code is reloaded. Wrapping initialization code, JS local storage, so set item, local storage, init at, okay, JS alert, true. All right, so it'll do that once. Do evaluates multiple expressions and takes on the value of the last expression. Bind is initialized to true once the setup is complete. In this case, we defined a variable called isInitialized that is only evaluated once and is bound to the value true once all initialization is complete. This is the first time that we have seen the do form. Do evaluates each expression that is passed to it and returns the value of the final expression. It is useful when there are side effects that we want to perform, in this case, setting a value in local storage and displaying an alert, before finally yielding some value. Combining do and def once is a common pattern for ensuring that certain code will only run only one time. Quick review. While Figwheel is running, and the line weather.cljs that contains def once app state, change the text and save the file. Does the page update? Why or why not? We did this before. It's because it's defined once, and the expression will not be run a second time. Find the line weather.cljs that contains h1 text at app state and change the h1 to p. Does the page update? Why is this behavior different from changing the definition of app state? Sure. Okay. Whew. Doing a quick stretch. Display business logic separation. The separation of display code and business logic is good practice in general, but it is even more important for reloadable code. Recall the append element function that we wrote several moments back when discussing idempotent functions. Consider that we're writing a Twitter-like application and use this function to append a new message to some feed. There are a couple of ways in which we could write this code, but not all of them are conducive to live reloading. Consider the following code, which does not separate the logic of receiving a new message from displaying it. So define receive message, the text and its timestamp. Let node dot create element JS document div set inner HTML node string timestamp text append child message feed node. Okay. In this example, we combine the logic of processing an incoming message with the concern of displaying the message. Okay. Now let's say we want to simplify the UI by removing the timestamp from the display. With this code, we would have to modify the receive message function to omit the timestamp, then refresh the browser, since our new code would not affect any messages already rendered. A better alternative would be something like the following. Def once messages Adam. Def n receive message. Text timestamp. Swap messages. Conj is like concatenate, I think. Text timestamp. Conjugate, I think. Conjugate. Render all messages. Set. Okay, so now we're setting the message to messages. Let node create element JS document div set string timestamp text append child. So this is definitely a renderer, and this is definitely something that just receives a message. Separating display and business logic. Okay, so let's look at how they break it down here. Number one, all messages received are stored in a def once to Atom that will not be overwritten. Okay. The function that handles new messages is pure business logic. Here, yeah, we're not doing any sort of rendering. The function that renders messages is pure display logic. Yeah, this is all rendering. And then perform the render. Yeah, okay. Render all messages. So we define the renderer and then we call the renderer. And the renderer uses our business logic to populate itself with data, with messages. In this case, we could update the render all messages function. When Figwheel reloaded our code, the messages list would remain untouched, but the display function would behave differently. And when render all messages is called, the display for all messages would be updated. The implementation note, the implementation of the above code is inefficient since the entire list is re-rendered every time we call render all messages. In later lessons, we will use the reagent framework to achieve similar results much more efficiently. Quick review. What are the pillars of reloadable code? Why is each one of these important? So it was, the pillars were, what was it called? Oh man. Code that runs once. I'm gonna peek. Idempotent. That's somewhat of a new way to put that for me. So I'm gonna look at why. Look up this word real quick. Why did they decide to use this? Denoting an element of a set which is unchanged in value when multiplied or otherwise operated on by itself. An idempotent element. Got it. Cool. That would be true here. Yes. Okay. Idempotent and def once, and the other one was separating business and display logic, or logical segregation, segregation rather. What is the difference between def and def once? Def once will only run once, basically. And define will run every time we reload. Or def will. You try. With Figwheel, we're going to try changing the text inside app state and saving the file. We already did that. What happens? Would something different happen if we had used def instead of def once? Introduce a syntax error in the code and see what happens in the browser. We did that as well. In this lesson, we examined a core feature of interactive development in ClojureScript, live reloading. We used Figwheel to reload our code whenever it changed, and we looked at the principles behind writing code that is reloadable. Equipped with this knowledge, we can take our productivity to the next level and enjoy much quicker feedback than we normally get with JavaScript. We now know how to start Figwheel from the command line, how Figwheel reloads code when it changes, and how to write code that is conductive to reloading. Like, I feel like everything that we've learned here is transferable to using just pure JavaScript or Node or anything else. Like, these are just good design principles, right? Like, sure. Okay, so what is the next lesson? Let's find out. Next lesson, where are we? REPL Crash Course, I think, is the next one. Receiving rapid feedback with Figwheel. Yep, REPL Crash Course. All right, so this is what I'll be doing tomorrow at a similar time. In the previous lesson, we learned how to use Figwheel to reload code whenever a source file changed, enabling a very quick feedback cycle. In this lesson, we will take a first look into a tool called a REPL, which stands for Read Eval Print Loop, and is conceptually similar to the JavaScript console that most browsers provide. While live reloading is a great help when we already have a good idea of the code we need to write, the REPL gives us an environment for writing more exploratory code, trying out ideas and algorithms before making them part of our project. Just like unit tests, REPL development allows us to test a piece of code in isolation, examining its output and making sure it matches our expectations. However, unlike unit tests, the REPL is more interactive and provides even quicker feedback. All right, so that's what I'm going to be looking over tomorrow. I'm excited about that. Definitely motivated to check out the Clojure REPL or the ClojureScript REPL. Awesome. When I come back, I'm going to be doing some Godot development. I'm going to probably take like a good, I might even cut the stream and restart it. I think I'll do that. No. But when I come back, we're gonna switch modes, and I'm going to work in Godot, and that is object oriented. I mean, there's some functional stuff in there, but it's primarily object oriented programming. It's game programming, and that is what we will be doing next in just a few moments when we come back. You Hey, I'm just dropping back in. I decided I'm gonna do the I decided I'm gonna do the Go development probably later tonight. I'll probably start at like 8 or 9 maybe. Yeah. Yeah, I think I'm gonna do that. So I'm gonna cut the stream now, but we will be back tonight around 8. All right, cool. See y'all then.